I'm going to talk about Ultrahaptics and multiview displays. I'm sure none of you have a clue what I mean by that, but hopefully I'll give you a glimpse into what I mean. But before I start talking about those kind of things, I want to unashamedly publicize my group. Yeah? So I work for the University of Bristol. We have a group that's called the Bristol Interaction and Graphics Lab, and we do research in different kinds of devices and so on. So we think of ourselves as a hub for collaboration between social scientists, artists, designers, and physicists and engineers. Myself being a physicist, so that's my background. We couple device design with public deployment and evaluation. So there seems to be something getting cut off there. Our research is rooted in human-computer interaction, so that's kind of what we do. And we work on different kinds of things. So we build hardware, we prototype things. We're really interested in novel display environments, novel haptic devices, deformable devices that can change their shape and morph from one structure to another. How do we do this? How do we take inspiration from origami and so on? So kind of things we do in our lab. So what I'm going to talk to you today is something that I've been thinking about for the last couple of years. It's about how do we think what's going to come beyond multi-touch? I mean, so multi-touch has become very ubiquitous today, and what's happening next? I have to say that a lot of things I'm going to show you, the images and so on, they're not finished stuff, so it's rough around the edges. It doesn't have the finesse that you've seen before from all the presentations. But what I want to do is to welcome you, take a look at our website at the end of the talk, email me if you find something interesting, and if you see there are opportunities to take this forward in any way. Like I said, this is all research prototypes, so nothing works outside our lab at the moment, but maybe it will in the future. So multi-touch, so we've all seen it. We've seen different sizes. We've got this handled iPhone, Galaxy kind of device. We've had these, what people call tabs now, different tablet size iPad kind of devices coming in the market that are already quite popular. We also have Microsoft Surface, Smart Surface. Oh, actually, it's not Microsoft Surface now. What's it called? Pixel Sense. So that's the new company. And different larger sized multi-touch surfaces around. So you can buy them off the shelf now, so it's no problem there. I think something like this costs about 2,500, 3,000 pounds, but still, it's available to purchase. And what this has done is it's spawned a whole plethora of applications. So you can think of lots of crazy things you can do with it. You can play music with your iPhone. You can, and today I've heard that most kids think a magazine is a broken iPad. So that's kind of what it is for them, right? So if you cannot pinch and zoom the magazine, then you're going to start crying. So this is the way kids are today. So it's quite common apparently, and YouTube is filled with those things. And companies like Smart Technologies and also Microsoft to some extent are exploring the possibility of replacing classroom tables with multi-touch surfaces. So they want to see what happens if you replace the table that's typical in any classroom with a collaborative digital table of this type, right? So you can talk to each other, you can control digital documents at the same time, and maybe engage with the teacher, right? So they're all possible, right? So there are lots of applications over there for multi-touch, but I have a problem with all of this multi-touch, right? So you can touch, but you cannot feel anything, right? So there's no feedback. I mean, just imagine, this is surely not what Michelangelo had in mind when he had this thing. So there's no feeling. So how do we give this haptic sensation back to people? Something that we've been curious. The other thing is, so great, we have multi-touch, but there are loads of applications where I don't want to have the same single view. I mean, I will show you some examples of applications where, like this in the retail setting. So this looks like it works fine, but if you are a retailer or if you work in the retail sector, you would know that you don't want a shopping window to look like this, because you just replace the shopping window that caters to hundreds of people to something that caters for two people, the two people who engage actively. Right? So you now alienated the 200 passerby who would potentially have become customers at some point. So in these scenarios, you may want to have multi-view systems, not just a single view. So how do you manage different views for different people? Okay, so really my talk today is about what are we doing in our lab to create this kind of multi-touch, multi-haptic, and multi-view systems. So when I say touch but not feel, so what I mean is I want to be able to do dual touch on an iPhone or an iPad. And by dual touch, I mean, so today, your iPhone has vibration, so you can take it out and it vibrates to give you some notification of a new email or something. But the whole device vibrates. I mean, and whether I want it or not, if I leave the vibration on, the whole thing is going to vibrate. So what if I can turn on vibrations at specific points in this device and turn it off at other locations? So only when I'm doing my two-finger pinching to zoom, each finger receives a different sensation to know which is the active finger, which is not the active finger, how is the zooming in and zooming out happening, and so on. So how do we do this? And so this is something that we're interested in. So it has to be multi-point haptic feedback, not just a single point. The other challenge that we had is it has to be through mid-air. I mean, I don't want to be touching the device to have this haptic sensation. Usually, the feedback that you get is too late if you've already touched the screen to activate something. So can I give you this haptic feedback before you've touched the screen? So as you're approaching the device, can you get a little bit of haptic feedback? So these are broadly the two challenges that we had for haptics, right? So how do we support haptic feedback on a multi-touch surface on multiple locations simultaneously and without physical contact? So I don't mean to say that physical contact is bad, but it's just we want something more than just physical contact. So as you approach, how do you give this feedback, right? So this is kind of what we're looking at. So how did we do this? So this is why we call it Ultrahaptics. It's a haptic system that we built. Again, it looks very rough here, using ultrasound transducers. So this is an array of 144 ultrasound transducers, which is basically speakers that emit ultrasound. And by controlling them, I can turn on and off different points, and I can give haptic sensations there. So the way it works is I have this array of transducers. I can, if I turn it all on, it generates pressure wave. So it's just some pressure wave that you generate. And at this point over there, I can get this haptic feedback. But the problem with doing this is I'm also going to get haptic feedback everywhere else, over here, over there, all around, right? So how do I control this? How do I make sure that it's only at one single location? This is kind of what we were thinking. So if we introduce a phase delay between each of these transducers, so we turn them on and off carefully so that they're not all on at the same time, but with a certain time difference, then the pressure waves all meet constructively at a certain point, and they destroy each other at other locations. So you have constructive interference happening. It's called, it can be thought of as sound holography. So this is doing holography with sound. So this is kind of what we're doing. Right. So here's a quick video of how this would work.
This video demonstrates the use of phased array ultrasound to create tactile feedback using air pressure waves. The waves generate enough force in the air to move pieces of paper tape. These forces are also sufficient magnitude to be perceived by a user whose hand is placed above the array. As can be seen in the video, the Ultrahaptic system is capable of generating multiple independent points of feedback. Preliminary testing has shown that users can identify and differentiate these feedback points with 87% accuracy. It is also possible to modulate the ultrasonic signals using lower frequency signals in order to generate a variety of perceptible tactile feedback stimuli. The multi-point Ultrahaptic system opens up new possibilities for the use of tactile feedback in areas such as mobile devices, entertainment, and gaming.
So it's really hard for me to show you how the haptic system works. So this is the best way we could come up with. Attach tape to the corners of the transducer array and show you the tape lifts off and comes down, so you can see that some haptics is happening there. Like I said, everything in our lab just works in the lab, and in fact, it's even worse. It only works when my PhD student is there. He needs to know how to turn it on. This is kind of how the system looks, or looked a couple of months ago. We were using XMOS, it's a company in Bristol. We were using their transducer arrays. This is kind of how it looked. And here's how it looks when it's finished, right? So it's pretty messy. But thankfully, we've compressed all of that into 3 little boards like this as of a couple of weeks ago. And in fact, I think we are working on the next version, so it's even more compact. So this whole mess over here is going to be nothing more than one board like this. So that's where we're going with this thing. But we're also interested in what we can do with this device. We're not just interested in building a haptic device, but we want to know what to do with the haptic device. So one of the applications we were looking at is viewing sports with the haptics. So because we can give you high fidelity, multi-point haptic feedback through air, what I can do is attach these transducer arrays to the back of the mobile device. And then if you hold the device appropriately, or if I stick my hand in the pocket with the phone in the pocket, I can, for example, feel Nadal moving on one side of the tennis court, Andy Murray move on the other side of the court, and feel the ball move from left to right. So I know which way the game is going. What I can do even more is I can change the temperature of the air on either side, and now you know who's winning and who's losing, right? So I can pretend to be talking to you here, but actually I'm following the game in my pocket. So that's possible. It would be even worse if I just pick it up and say, hang on, I want to watch the scene now. So this is kind of where we're going with it. Actually, I'm going to skip this part. So that was an envisionment of the system, and this is how it looks, right? So again, it's a bit clunky. So this was an Samsung Ultra mobile PC that we got from 2008 or something. So we've got this, and we've built this array on the back. And this is kind of how the prototype looks. And the postdoc at the time, who was very interested in Formula 1, he encoded different bits of Formula 1 video. So if Jensen Button's car goes over a bump, you feel a bump on the back of the device. If 2 cars make contact, again, you can feel that contact on this device on the right corner of the phone. So you can. This is kind of how we were approaching this thing. Since then, we've had some interest from different theme parks in the US and places like that. So one of the things that we're looking at is putting this haptic device on the in chairs or on the floor, right? So let's say you're watching Shrek or some other movie, and you can feel the characters walking through a swamp, or you can feel the rats running around your legs, or as this picture tries to depict. If you had a really high-resolution haptic system, you can have a snake creep up from the back, and you imagine if you're watching a cinema movie, and you can feel some sensations at the back of the chair, and then suddenly the snake comes in front of you. You need to probably sign a disclaimer before you go watch this movie. So this is a bit, it's not likely to happen in the next 3 years, 4 years, but we're really hoping to be able to push the technology in these scenarios and so on. Again, something that's very popular these days is second screening. So you have 2 screens to watch when you're watching TV or anything. So you use the second screen to Twitter or do any social media. Again, we can probably augment the second screen better with some haptic information now that we can do high-fidelity haptics. But here's the thing, right? So I said I'm going to talk about haptics and I'm going to talk about multiview. And we started doing this project with multi-point haptics. And then we thought, well, hang on. I can create this pressure wave, and I can give you sensations in your hand. But why does it have to be your hand? It can be any other physical object. So we thought we can actually move stuff around. So imagine that I built this haptic ultrasound transducers around the rim of your iPad. So you have the sleeve that you can put on top of your iPad, and these ultrasound transducers are all around it. You can play mixed reality Pong, right? So you can try and control this paddle over there, and there's a real ball there that's moving back and forth, right? So you can do that. Here's what we did. So we just stuck a camera on the top to track, and does it work? So if I can move the object, so you can just look what's happening here. So So that's great, right? So I can move one object, but I can do better. I can move two of them simultaneously, right? Even you can imagine. The holy grail for us would be if you have chess over there. It's like the Harry Potter scene, but it relives the character. So the chess pieces jump around. The knight jumps over all the pawns and moves to a different location. That would be nice. I think Tom would hate me for saying that, but. There are other applications, right? So again, if you talk about these kind of multi-touch surfaces in classrooms, again, if you had a huge map like this one, and if you have physical props that represent your start and end points for destinations, if you zoom on the map, these start and end locations have lost their relevance because these are physical props that they don't move. But with the system like this, you can move them. So you can bring in tangibility and physicality even to map navigation, different kinds of applications. Or you can take Angry Bird to a whole new level. So it would be quite fun to do. So we really got interested in being able to actuate devices from this way. So we thought, OK, we can actuate little objects one at a time on the screen. But what if I can change the whole screen? I can start moving the whole screen. So this is what we started doing. So we built this thing called what we call tilt display. Basically, this consists of 9 small displaylets, and these displaylets can move up and down. They can tilt in different axes. So it looks a little bit like this. So you can imagine, you can see flowers blossoming and so on. So yeah, I should probably, here's what's most interesting. So we didn't do this user study in our lab. We didn't want to be biased. So we did this user study in Nokia in Finland. And this is what people said about this device. So I was really amazed. I cannot believe that someone would say that they would rather use our device than go to Hawaii. So maybe we paid them too much, I don't know. But nevertheless, I think devices like this can be quite evocative, and people can visualize and feel and see things much better, right? So Bristol, where I live, is quite a hilly city, and especially from where I am to the lab, it's a nice steep hill. And Google Map never tells me that it's a steep hill. But maybe with a device like this, you can see that actually it's a hill, okay? So I will show you the video of this.
This video introduces tilt displays. A tilt display is a physically mutatable visual feedback device whose display components support multi-axis tilting and actuation. We implemented a prototype.
Why?
Visual and physical output.
Sorry, I don't know
We
what happened
demonstrate a sample of applications that utilize tilt displays for output modalities. 3D models have static visual content and, once in position, static physical content. In this example, the tilt display shows the terrain of a map. 3D fixed mode provides dynamic visual content on a fixed physical setup. In this example, the tilt display is used for collaboration. Each of the two viewers have their own areas of the display. This idea can be extended to larger groups by appropriately tilting portions of the display. In this instance, 4 people are passing photos amongst themselves. 3D movement has a static visual output and a dynamically changing physical configuration. Here, a 2D photo of a flower slowly forms into a 3D representation. By combining both dynamically changing...
All right, so I'm going to stop this one. People sometimes ask us, why 9 screens? I mean, it looks rough. The edges are, there's all this gap between the screens. It was just a proof of concept prototype, right? So it was to prove this, that it would be interesting to have a mobile device or a handheld tool or device where the screens can tilt along multiple axes. There's nothing special about the fact that we picked a 3x3 grid. The only reason was it was the easiest. We could find 1-inch displays where we don't have to write display driver software, so it was easier for us to do things. That was the only pragmatics that determined what we did. So, like I said, I mean, there were two elements to my talk. One was this thing about multi-touch, and the other thing was about multi-view. So really, multi-view, the notion came about because we were talking about augmenting retail windows, and the Watershed is a nice cafeteria and a cinema place in Bristol, and we were thinking of putting a see-through display there on the front of the glass pane of Watershed, and quickly we realized it's a bad idea because if we put this as multi-touch see-through display there, 2 people would be able to interact with this, and the remaining 20, 30 people who walk by would just keep ignoring because there are 2 people there in front of it. This is what led us to start thinking about how do we support multiple views around this. And I know sometimes it may seem like a technology approach to a user interaction problem, but hey, we are technologists, so that's what I did. So this is what we did. But it's not just about shopping window experiences for high street shops, right? But it can also be for museums and galleries where you want to mediate interaction with these precious artifacts. You don't want people to pick it up and look at them. At the same time, it's unlikely that these 2 groups of people want to look at the same type of information about it. Right now, you have this weird setting where you can see this rare earthen pot in front of you, but you have one of these, what do you call this, headsets where you hear what's going on when you press a different button. And you can press different buttons depending on what you want. But it would be really nice if they were all co-located, so you can pull up digital information about the object depending on where you are. Okay, so this is the scenario we envision, right? So there are 2 people, they look at what looks like a teddy bear. One of them can get information about brown bears in general, their habitat, their loss of habitat, what's going on in nature, and so on. The other person can get information where to get your own stuffed teddy bear, right? So all looking at the same bear, it's possible. I'm not going to go into great depth into how we do this thing, but this is kind of what we do. We just taken apart liquid crystal panels. So what we've done is each liquid crystal display, so the display that I have here, most of your laptops and so on, they have a liquid crystal panel, and that panel is managing light polarizations. And what we've done is we've carefully structured assembled a new piece where we have 2 liquid crystal panels instead of 1, and by that we're managing polarization in a much more controlled manner. So that way different people can see the objects differently. So that's kind of what we do. But once we built this, we thought actually there is also tabletop applications, right? So if you have a large table, like the kind of things that Microsoft and Smart are thinking of putting in classrooms, it's not that everybody wants to be collaborating all the time. I mean, we all love to collaborate with each other, but we also want to do our own little thing at times, right? So typically, someone goes off, does something else, they come back and they're confused. They don't know what's gone. I mean, so this person who's gone off doesn't know what's going on in this table. So if, again, you can manage the views separately for these people on the same table. So the person who wants to do the private task can still stay on the same location, keep an eye on the collaborative activity that's going on, but just lean back maybe to do their private thing, and then lean forward when they want to do the public thing. This is the scenario we wanted as well. So this is the second version that we did. I'm going to show you the video from 202. Yeah. Is it working?
To demonstrate how pivot can be used. The shared view shows the world map.
So here's how it looks. Look, if you lean forward, you get extra information, like the place of interest, okay? And then if you put an extra tag, that information there is only visible to the person who dropped the tag in, okay? So you can see the Leaning Tower of Pisa is only visible for the camera, not from any other viewpoint, okay? So when the camera now steps back, you don't see it. So it's so that's the way we know where we can manage different views, right? So if you sit back, you have this public view, you see the Google map. But if you lean forward, you get extra information, okay? So here's another application for we call anatomy applications. So these are very simple ones, but still. You see some extra enhanced information that's only visible when you are in a certain position. So this is one type of a multi-view system that we've built, which manipulates liquid crystal and light polarization. The other one that we were really interested in is one of the problems with this kind of the previous types of displays is that you cannot stick your hand in and interact with the 3D object if you have it, right? So we wanted to really build a display where I can stick my hand into the 3D object, manipulate it, or in a multi-view system. We thought water would be a great thing because that's one thing that we don't have in our lab, that we play with everything else. So we wanted to build a water display. What happens is there's just there are these nozzles over there which are dropping controlled drops of water through a valve. And we track these drops of water and we project onto them. So we create water display. So if you project onto that, it looks something like this. It's not amazing resolution, but it's getting there. Okay, so if I had two, so if I have 3 layers over there, right? So and I can have these nozzles one behind the other, then I can make sure that there's an offset when these drops are falling. So between the drops of one layer, you have drops of the other layer, and that way you can assemble a 3D structure. So if you have 2 layers, you can see that's one layer, and this is the second layer, okay? Or you can have 3 layers, 1, 2, 3. You can project something like this, so you can see. It's not that visible, but actually there are 3 tubes over there. 1, 2, 3. That's the 3 layers, and this looks like the 3 different things. Do you know what it is? It's a smiley face. Yeah, exactly. So if you just come in front, you see a smiley face. Yeah? So it's it seems a bit lame, but. But that's all we can get so far, right? So this is about 15 nostrils, and we are still working on this. So, but the nice thing is now you can stick your hand into this display and you can start interacting with it. So it's possible. Most of you know this scene. You know this movie, right? Yeah. Okay. So so he's lifting something up and he's able to throw it out. This looks like science fiction. And I know as a technologist, I draw inspiration from these kinds of movies. And someone said that's science fiction, and we don't think it is science fiction. We think it's doable. It's definitely within the realm of possibilities. Maybe not today, maybe not tomorrow, but certainly in the next 5 to 10 years, it's doable. And so that's kind of where we're going with our own lab. So I want to conclude. Really, what I was showing you is point designs. By that, what I mean is just proof of concept prototypes demonstrating that we can do such things. We've not by any means attempted to understand all the user experience issues around these things. And in fact, I would invite you all to critique, comment, take it, trash it in whatever way possible. We would love to hear from you because that's also what inspires us. So when you challenge our assumptions, we can go back to the drawing board and do something interesting with it. So that's all I have to say. And I have to thank all these people. I didn't do any of this work. It was all these people who did the work. Yeah, thank you.